Hey everyone. Today we are going to talk about hypothesis testing a little bit more. But specifically, the hypothesis testing we're doing today is for when we take a sample, a large sample, from a population, large being anything above n equals 30, and we're testing for the mean here. So we have to be given some claim that has to do with the mean, and we're testing whether that claim is true or not. Or I guess more specifically, we're testing to see if we have sufficient evidence to say that the original, the historical mean, is no longer true. So we would reject that. So when n is large, so these types of problems, you're either given the mean of the sample that we've taken, you're given the sample size, and sometimes you're given the population the population standard deviation, but the population standard deviation is not something that's readily available for most populations, since the whole reason we do sampling distributions is because we don't have a complete picture of the population. So we take samples to draw that picture of the larger population. So we're usually given the sample standard deviation, and if n is large enough, n greater than or equal to 30, then we can say that the sample standard deviation provides a good approximation of the population standard deviation. And that's what we're going to be doing for a lot of these problems. Actually, all of them. So let's start with an example, and we'll walk through how to do this, and we'll be bringing up all the things we talked about last time as we go through this. So hopefully that'll reinforce what we learned last time as well. So here we have employees in a large accounting firm. They claim that the mean salary of the firm's accountants is less than that of its competitors, and the competitors is $45,000. A random sample of 30 of the firm's accountants has a mean salary of $43,500 with a standard deviation of $5,200. At a 0.5 or 0.05 significance level, test the employee's claim. So what does all of this mean? Well, so first of all, when we think back to what we learned about when we did normal distributions, because the sample size here is 30, that is large enough for us to say, you know what? We think, regardless of what the population looks like, we think that the sample that we're taking is approximately normal. And we can say that the mean is right here. And this is the mean that's claimed for the other corporation is 45,000. So this is a one-tailed test because they're just claiming, the person here is saying, the employee is saying, you know what? I think our salary is less than that. So they're saying, we think it's less than that $45,000. Now, our goal here with the 0.05 significance level, that means if the probability of getting a sample mean of 43,500, if the probability of getting a sample with a mean this large is less than 0.05, then we can reject the null hypothesis. Otherwise, we fail to reject the null hypothesis because we don't have enough evidence to do that. And so the 0.05 is really saying, is $43,500 below the value that I would get if I was talking about just 0.05%, or not percent, sorry, 0.05 for the area. So 5% of the area under the curve is down here somewhere. Is the $43,000 outside of that range, or is the $43,000 actually going to be inside of this range? And that's what we're trying to determine. So we need to start by actually finding or creating a null hypothesis for this. Okay? So our null hypothesis mathematically, whenever you make a claim, there is some historical thing that's already been there. It's the status quo. Okay? They're saying there's this other firm that is giving us giving its employees $45,000. So our null hypothesis, H sub 0, is going to be, maybe I should just draw it. I'm just going to put H0. And that null hypothesis is that the mean is equal to $45,000. The alternative hypothesis, the claim that's being launched here, the claim by the employee is that, you know what, we're not making that much money. So we're making less than $45,000. So that is the mathematical way to identify the null and alternative hypotheses, which you've already done in the previous problem set. So now the next step is to calculate the p-value using our techniques that we've already learned. We learned about how to find the p-value. Okay? So if I want to find the probability of a sample mean being less than $43,500 in a population with a mean of $45,000, I need to know what X is, I need to know what mu is, and I need to know what the standard error is, the standard deviation of the sampling distribution. So the standard error. So I don't know why I can't get this to say what I want it to say, but I want it to say mu, and it would not type that. All right. So X is going to be the 43,500. Mu is the population mean, which is the $45,000. And my standard error, since I don't have the actual population standard deviation, I'm going to approximate this with the sample standard deviation, which was 5,200, divided by the square root of 30. And so my standard error is about $949. So let's calculate the probability that a sample of 30 people would have a mean that's less than $43,500. So let's recall how to do this. To find the probability of having a sample mean with that is less than or equal to 43,500 or less than 43,500 is going to be, I'm going to use the norm.dist function, and that's going to be x, comma, the mean, comma, the standard deviation, comma, true for cumulative, and that comes out to 0.05705. So the probability of a sample of these accountants. So first, let's just talk about whether we're going to reject or fail to reject the null hypothesis. In this case, we fail to reject the null hypothesis. Now, why do we fail to reject the null hypothesis? Because the probability that I get a sample mean of 43,500 is larger than the significance level that I set out at the beginning of this problem. The probability would have to be smaller than this value for me to reject the null hypothesis. So in this case, it's bigger. It's just a little bit bigger, but it's bigger. And so what this means is that there is not enough evidence at the 5% level of significance to support the claim by the employee that the mean salary there we go, do not disturb, that the mean salary is less than $45,000. Now, again, what does this mean? The mean is clearly less than $45,000. Why did this happen? Why are we rejecting this claim? We're rejecting this claim because within any sample that I take from a population, there will be variability. The difference in the sample mean is due to the variability of the sampling distribution. So that's what we say. We can say either of these things. There's not enough evidence to support the claim. And what that really means is that the difference in the sample mean that I just got, 43,500, and the one in the population mean is just due to regular variability. Remember, 3 standard deviations within the mean is still normal. And so in this case, about $1,500 would have been right on the edge of being outside of 3 standard deviations. But it's still not outside of 3 standard deviations in this case. And actually, 3 standard deviations would be if my significance level were at 2.5 or 2.35. So this is actually a little bit in farther. So it's not quite 3 standard deviations, but we're still saying we want this significance level of 0.05. So we have failed to reject the null hypothesis. So that means we are saying that whether we're right or wrong, that the $45,000 is the mean of the population. That's what we're saying. The mean is $45,000. So what's the only type of error that could occur here? Well, type 2. Why type 2? Because we failed to reject the null hypothesis. So if we fail to reject the null hypothesis, that means the only mistake we could have made is if the actual null hypothesis was false and we called it true. There's no way I can reject the null hypothesis and that ended up to be true. I did not reject the null hypothesis. So the only mistake I could have made, there's only 2 things that could have happened here, is this is a type A situation and we failed to reject, and it turns out that the null hypothesis was true, so we nailed it, we were right on. Or the other option is that we should have failed the null hypothesis. We should have rejected the null hypothesis, and we didn't, meaning the null hypothesis was false, but we said it was true. We set a guilty man free, potentially. Which we'd rather have the type 2 error than the type 1. All right, we'll come back in the next video. I'm going to do this in regular Excel, and I just wanted to be able to draw on this so you could see the picture. And then we'll do another example, and this one's going to be two-tailed instead of one.